Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to sensors and transducers, and sorry, because of some reasons I was not able to record and upload videos in the recent few days. So now we will be uploading videos regularly. So today's topic of discussion is liquid level measurement using bellows. Okay, so we have already discussed bellows, which is a mechanical transducer, primary mechanical transducer. Here we'll be discussing about the application of bellows for measurement of liquid level measurement. So just a quick recap. We know bellow is a primary mechanical transducers, which is basically used for the measurement of force, pressure, because they are interrelated. So as it is a primary transducer, it's a mechanical transducer, so the output is basically mechanical movement, physical movement. In order to convert it into suitable voltage or current signal, we have to connect it to a secondary transducer, electrical transducer, which can be LVDT, which can be an inductive transducer, capacitive transducer, potentiometer, anything, so that we can get a proper voltage or current signal output. Then we can feed it to suitable signal conditioning processing circuitry to get a proper output. So the bellows, the construction of the bellows, it's basically a cylindrical structure with a number of folds. These folds, these curved shaped elements which are stacked together, they're separately designed, and then they are connected. So these folds are called as convolutions or corrugations. Okay, so this is kind of a cylindrical shaped structures with two free ends. Okay, and it is made of special elastic material, special alloys which are elastic in nature, and the materials that are generally used, as I said, special metallic alloys, rubber, plastic, or other elastic material. Okay, and other specifications which are to be taken care of while designing the bellows are the diameter should be in between 7 millimeter to 150 millimeter, depending upon the range of pressure measurement, while the thickness, the corresponding thickness, should be from 0.08 millimeter to 0.3 millimeter. So basically how the bellows they work is that when one end, free end, is connected to the source of force or pressure, whatever that is, pneumatic pressure, hydraulic pressure, whatever it is, this is flexible. This cylindrical portion is flexible. The other end, it kind of undergoes expansion or compression. Okay, depending upon the pressure difference between the inside of the bellow and the outside. If the outside pressure is high, naturally, because of the high pressure on the outside, it will expand, and when the pressure inside the bellow, it all depends on the external pressure and the internal pressure. So that results in, this is the original position, let's say. Okay, this is the original state of the bellow. Depending upon the pressure difference, it can undergo expansion or it can undergo compression. Okay, this free end, this is one free end is connected to the source of pressure. This free end, it can be connected to an LVDT, okay, or a capacitive transducer, resistive transducer, or inductive transducer to get us a proper voltage or current output. Okay, so it all depends on the flexibility okay, the flexibility of the bellows, so that it can expand and compress accordingly to respond to the pressure difference. And therefore specific materials, as I said, special metallic alloys, rubber, plastic of certain specifications, they are used for their design. The mathematical expression for the displacement, the axial displacement, this is the axis. So the axis, the displacement, let's say along the y-axis, this displacement along the y-axis, if it is placed along the x-axis, it will be represented along x. If it is placed along the z-axis, it will be represented along, in z, that way. So here, the axial displacement, because of the differential pressure difference, delta P is external pressure and internal pressure, that difference. Okay, so that is related to, okay, this is related to the pressure difference along with other parameters also, which are constants. So this is the output that we get, the mechanical movement, displacement, okay, and this is the thing that we are measuring, the pressure difference. And then the rest, they are constants. So pi, that we know, Rm is the mean radius, which is outer radius plus inner radius divided by 2. Then delta P is the pressure difference, 1 minus mu square, mu is the Poisson's ratio, E is Young's modulus of elasticity, T is the thickness of the walls, because outer radius, inner radius, it's different. So the thickness of the walls, this circular stacked structures which are placed one above the other, the thickness of that is T. Then N is the number of such corrugations, curved structures, the number of such. Here it is 1, 2, 3, 4, 5, 6. N is equal to 6. So depending upon the design, the pressure measurement range, the number of convolutions can vary. So N is the number of convolutions or corrugations. A0 and B0, they are constants which depend on the type of material which is selected, whether it is alloy, whether it is rubber, whether it is plastic. So it is specified in the chart, the specification sheet which is given along with that particular sensor. It is provided by the manufacturer. Then again, T is the thickness and Ri is the internal radius of the bellow. Okay, so this is all about the bellows, how bellows measure pressure. So how we can use it to measure or find the level of a liquid. So the basic principle here is that, let us say we have a particular liquid in a tube or container or whatever structure it is. Okay, we know that the pressure exerted by a liquid column is given by this rho g h. Rho is the density, g is acceleration due to gravity, and h is the height of the liquid or the level from the reference datum. Now sorry, here there are two conditions. One, when the liquid column is exposed to the atmosphere, and the other case where it is closed. So here we are considering when it is exposed to the atmosphere. So the atmospheric pressure will also come into play. So the total pressure here is the liquid column pressure exerted by the liquid column, and the atmospheric pressure. The atmospheric pressure is constant, means for that particular measurement is constant. So what we do is that the sensor, whatever sensor we are using, here we are using bellows, the free end, one free end of the bellow is connected to the liquid column through suitable channel, and the bellows, it measures the total pressure. The sensor, the bellow, this measurement, this is the sensor measurement, PS, the pressure measured by the bellows sensing element. It measures both the liquid column pressure, rho gh, and also the atmospheric pressure. So here we subtract PS minus P atmospheric, which gives us the liquid column pressure. Now the liquid column pressure is equal to rho g h. Here the principle is, if we know the density of that particular liquid, here this is the important condition here, okay, this is the important condition. This density of that particular liquid, which the level of which we are measuring, that should be known to us, that should be known. This is the important condition. Without this, there will be two unknowns in this equation and we cannot do anything about it. So the liquid density of that liquid, it should be known. So when we know the density of the liquid, g is acceleration due to gravity, that we know, that is known. So we can determine the level or height of the liquid by this PL by rho g. This will give us the level or height of the liquid in the container or whatever tubular structure, well, whatever it is. Okay, so this is the simple basic principle of level measurement of a liquid using bellows as the primary mechanical transducer. Okay, so this is the simple basic principle. So the first thing is the bellows, they measure the pressure due to the liquid column and the atmospheric pressure. As the atmospheric pressure is known, we subtract it from the total pressure, which gives us the liquid column pressure. Liquid column pressure is given by rho g h. Rho should be known, density should be known, density of the liquid. Only then we can determine the level or height of the liquid h. Okay, so here let us try to understand this whole thing from a three-dimensional perspective. So here we have this tube-like structure or container in which the liquid is present, the level of which, the height of which we want to determine, density is known. So here, according to the change of level of the liquid, the pressure exerted by the liquid column, it varies. Atmospheric pressure is known for a particular thing. So depending on that, this bellow, which is connected at the bottom, okay, which is connected at the bottom, this, it undergoes compression or expansion like this. Okay, this is the bellow bellow structure. Okay, it undergoes compression or expansion like this. So as a result of this, the free end, which is free to move, which is free for mechanical movement or displacement, axial displacement, which is connected to the suitable pointer scale arrangement or electrical transducer, that movement causes a voltage or current signal, which gives us a proper electrical corresponding output of the pressure. And then the remaining principle, P is equal to rho g h, density is known. So acceleration due to gravity, that is also constant, that is also known. So from that we can determine h, height of the liquid, h is equal to PL by rho g. Okay, so this is the basic principle of operation of bellows. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.